civil engineering student in the Universidad de La Salle from Colombia, and today I will talk about wood waste as an alternative thermal insulation for buildings, as a work corresponding to the subject of the science of materials and concrete. In this study, a natural fiber material in form of wood waste is examined experimentally to assess its suitability for use as thermal insulation material without the addition of any binder, within a timber frame wall construction. The plant-based materials sequester atmospheric carbon dioxide through photosynthesis, and consequently their use in construction can reduce the net embodied carbon dioxide of a building. In the image on the left, we can see how is the process of photosynthesis, where the plant receives sunlight and water and transfers carbon dioxide into oxygen. Further materials experimentally studied the potential applicability of woven fabric waste, or WFW, and woven fabric subwaste (WFS) as a thermal insulation for use in construction. The results showed that the WFW had a better insulation characteristics than the WFS, and the thermal conductivity value of WFW was similar to the conventional thermal insulation materials. The hydrothermal behavior and material. This behavior considers the simultaneous and interdependent occurrence of heat absorption, storage and release, and moisture, liquid and vapor absorption. The WW material used came from wells and from the manufacture of furniture and carpentry. The material was used as received without the addition of binders. The experimental methods. The experiments conducted to determine the apparent density or bulk, thermal conductivity, water vapor transmission properties, true density or absolute density, water absorption coefficient, and hygroscopic sorption and desorption properties. In most cases, 3 samples of the same material we use and compare. Experimental results and discussions. First, the thermal conductivity and density, apparent density. The results are present for both oven-dried WW and conditioned WW wood waste. While is the expected general trend of increasing apparent thermal conductivity with increasing density, increasing moisture content and increasing temperature is apparent. Also, in the lower graph, you can see the comparison of wood waste with other materials. The hygroscopic sorption and the desorption properties. According to the results, the biggest difference in the moisture contents of samples were calculated for 93% during desorption. The moisture content increased approximately 11% at desorption and decreased approximately 9% during desorption, all this across the same range. The vapor transmission, true density, and porosity. These results indicate that the wood waste WW has a lower vapor resistance at high relative humidity compared to the low relative humidity conditions. The porosity results reveal that wood waste and WW is comparable to the other natural fiber materials. Like conclusions, wood waste can be applied to timber frame wall construction by manual filling or mechanical blowing of the loose fill material between the studs of the frame and without any binder. The density of 117 kilograms for a cubic meter was found to the functional density level that can be achieved without mechanical compression and has a thermal comparable to similar materials.